Hello, I'm Laura Lewis. Welcome to this class on life on Earth and the formation of the atmosphere. Okay, so in this video, we're going to look at answering some exam questions on the development of the Earth's atmosphere and about how life has changed it, because there's quite a lot of information here. I'm going to go through it not quite methodically and slowly. I'm going to include a lot of information in this video, so it'd be good for obviously you can play it back and things to write this all down, because there's lots of information based around this topic. Obviously it's the formation of the Earth going to be a lot of, it's very, very interesting though. So it's one of my favorite things to teach is the formation of the atmosphere and the planet Earth. Okay, so I'll start off with a 1 mark question. This is from an exam paper, GCSE chemistry 1. So it's this it introduces itself as, this question is about life, the Earth and its atmosphere. There are many theories about how life was formed on Earth. Suggest one reason why there are so many theories. So it's only 1 mark, but it's actually quite a difficult question in a way, isn't it? And the way I think about it is probably, it's actually more straightforward than you think it is. As say there, I'm going to answer in a full sentence. There are many theories of how life was formed on Earth as it happened many billions of years ago. It's billions, not millions, billions of years ago. It happened many billions of years ago, and there is not sufficient, so this means enough, evidence. Yeah, because this is what you have to say it scientifically. You can't just say, well, there wasn't any humans there, because I mean, it's kind of true, but it's not very scientific. We need to say it in a scientific way. There is not sufficient evidence of the earliest life. Okay, so I'm going to add a little bit to this. I mean, you get 1 mark for that, but I'm going to add, obviously, because we're sort of talking about exams and exam technique. So we're going to sort of think about it for a minute, so that about why this might be. The reason is, because I don't like just writing something and there's no reason for it. The reason is that the first living organisms were most likely microscopic. It's like sort of a bit like bacteria, and soft-bodied. They haven't got any bones or anything, or shells, so did not leave any fossils. We don't have any direct evidence of it. Obviously, we have some scientific reasoning, but we don't actually have any direct evidence of the fossils around that time. Okay, so we've got an explanation there. Let's get to a long question. This is all lots of information in it. Okay, so actually, because it's so interesting, this topic, you kind of tend to remember it, because yeah, if you sort of look into it and research, and there's lots of videos on YouTube and things about this, and you watch, you can watch videos and like documentaries and things. I always think it's a really good topic to go into. Okay, so in this question, there's 6 mark. As soon as you see that in this question, it's a 6 mark question. In this question, you'll be assessed on using good English, organising information clearly, and using specialist terms where appropriate. Okay, the Earth and its atmosphere today are not like the early Earth and its atmosphere. It's an oversimplification, isn't it? But it's true, but it's a very simple way of saying it. So let's see, we've got 2 images here. Okay, so it's the early Earth, but most of the surface was covered by volcanoes. Yeah, so the early Earth was molten, so it was like kind of like a big ball of molten lava. If you've ever seen the Star Wars films, it looks a bit like Planet Mustafar, which is like a big yeah, it's a planet that's molten and full of volcanoes. Within our solar system, there's a moon of Jupiter called Io, which is covered in volcanoes. That's what Earth probably looked like in its earlier stages. Okay, so because it formed from the sun, formed from a nebula. You don't need to know this in this question, but I'm just saying as background because you could get a question based on this. The sun was formed from a nebula, so a big cloud of gas which collapsed, and basically only the gas and dust that didn't form the sun formed the planets. Okay, so we had the sun a little bit before the planets. Sun's a little bit older than the Earth. Okay, so and it formed from what's called accretion, so basically rocks, so dust bashing into each other to make rocks, and rocks bashing into each other to make bigger rocks, and eventually planets, and that would obviously create a lot of heat, so it's molten. Okay, that's what's covered in volcanoes, because it's molten, giving you why it would look like that. Okay, so it says most of the atmosphere was carbon dioxide and water vapor. Okay, so that's very different to today because we don't actually have the majority carbon dioxide or water vapor, and we're told that the Earth today, most of the surface is covered by oceans. Yep, so look, that's why we generally call the Earth the blue planet, because most of it's oceans. And it says most of the oxygen, the rest of it's obviously land and deserts and things like that, and ice. Most of the atmosphere is nitrogen and oxygen. Yeah, so 78% nitrogen, about 20%, 21% oxygen, 1% other gases, 0.04% carbon dioxide. So carbon dioxide is definitely not the majority. Okay. So always have a look and have time to sort of understand the question a little bit, because it's not good to rush these 6 marks. You think, oh, no, 6 marks, but it's not good to rush because you tend to make mistakes like that. I see lots of students that have kind of been frightened by 6-mark questions, but if you just take time to read it and understand it a little bit. So sometimes you might want to do 6-mark questions, or the questions which contain 6 marks first in your exam. You don't have to do the exam in order. Okay, so if you go through and you see the first question, you don't have to do it. Do not panic. Just look at the next question. You might be able to do it. Honestly, I've done that many times at university. I've gone to the first question, didn't know how to do it. Next one I did, and so on. So if you got most of it right, and you can get that one, you're most likely to pass it. Okay, and that was okay. So no panic. Okay, right. So let's look at the actual question here. Describe and explain how the surface of the early Earth and its atmosphere have changed to form the surface of the Earth and its atmosphere today. So it's the surface of the Earth and this atmosphere. This is it's a very good question. That's why I cut this out of an exam paper to discuss, because it's talking about both. Okay, you've got 2 in 1 here. Okay, so surface of the Earth. Okay, so let's do one at a time then. So how the surface of the Earth changed. Okay, it's always good to sort of separate it out, because then you don't forget it, because if there's like 2 parts to it like that in 6 mark, you can forget one. So the surface has changed. So the early Earth, that's what they called it there, isn't it? Okay, the early Earth was covered in volcanoes. Okay, we take what we've been told first, and molten, and mostly molten. So over time, the Earth's surface cooled down, because the core is still quite hot, but the Earth's surface, we're talking about the surface, not the inside of the Earth. The Earth's surface has cooled down and solidified to form rock. Okay. If you look at volcanic eruptions in places like Hawaii, Iceland, you can see that the lava comes out of the volcano and it cools down, it forms rock. Well, you might have a piece of lava rock at home in your house. Okay, I've got a piece from Lanzarote. That was lava, it's cooled down. That's what happened in the early Earth, but it had lots more volcanoes. Okay, solidified to form rock. So let's think about the next bit. It's kind of to do with the ocean and the atmosphere. So the water vapor was in a gaseous state. So it was a gas. Water vapor is a gas, isn't it? If you look what comes out your kettle, gaseous state. Because the Earth was so hot. The early Earth. Okay, the early Earth was so hot. This cooled down and condensed, a bit like when you put a kettle near a window, condensed, and the window glass is colder, to form the oceans. Okay. So the oceans, a little bit of bonus information here, were also formed from comets. So they are made of ice and rock. There's a lot of ice in water ice in a comet colliding with the Earth. Okay, so once we had oceans, so once the oceans formed, the carbon dioxide in the atmosphere could dissolve in the oceans, because carbon dioxide is soluble in water. So if you've ever drunk a fizzy drink like Coca-Cola, lemonade, anything like that, or like Fanta, that's actually carbon dioxide is dissolved in the drink to make it fizzy like that. So carbon dioxide dissolves in water. Also, it's a bad thing as well, because with carbon dioxide emissions from things like cars and factories and things, it can dissolve in the oceans. Obviously, more than natural cause. And it can cause the ocean acidification, and that can kill marine life like corals and things. But yeah, carbon dioxide is dissolved. So also, carbon dioxide was formed into carbonate rocks in the ocean. That things like chalk and limestone. Also, some marine animals will use the carbonate in the water to actually form their shells. You know what carbonate, if you live in an area with what's known as hard water, it will form in your kettle lime scale. That's really a form of carbonate rock. Lime scale, yeah, is actually a rock forming in your kettle because the water's got it's got carbon dioxide and other dissolved minerals in it. So yeah, that's what happens in the ocean. You get chalk, like the cliffs of Dover are formed from chalk. Okay, next question. The carbon dioxide. Yeah, so actually another difference is a very I nearly missed this out. Needed to miss out. There's a subtle thing here, where there's continents here in oceans. This didn't have any continents. So over time, the surface of the Earth formed a crust. Okay, put it on bread, which was cracked in places. So this is a little bit like if you had a boiled egg. So don't write this in the exam. I'm writing this down just to explain it. Like a boiled egg's shell. Like if you had a boiled egg and you cracked it, like a boiled egg's like the hard egg. Like if you boil it a long time, you cracked it and then it's got cracks, but it's still intact, but it's got cracks. So I'm going to put that in. So don't write that down in the exam. But I think they'd take marks off you, but I don't think you gain any marks for writing that. And formed, but it's good to think of it like that. And formed, and formed the tectonic plates. Okay, these tectonic, yeah, lots of things going on. As I said, lots of information here. I mean, don't need to have all of it for the 6 marks, but it's good to know about all these things so you will remember enough to get 6 marks. Okay, so yeah, I'm fascinated with this field. I think it's quite interesting to get into. Geology and earth science is very interesting to get into. See, tectonic plates moved around because they move around all the time, and formed the continents. Okay, so they're still moving today. Okay, but they move so slowly, they move centimeters a year. So it's like a whole continent, like Africa or Asia or Europe. Okay, so it's sort of kind of part of Asia, but they will move around a bit. So over millions of years you notice it. You don't notice it year on year, but over millions of years you notice it. Okay, atmosphere. I mean, some of these things do interact with each other, so sometimes you can't really split them too much. Okay, so lots of things happen in the atmosphere as well. So algae evolved. So algae is sort of that green plant you find in ponds. Okay, so they're sort of single-celled little plants. Okay, so algae evolved and started, because these were before other plants. These were the first things, algae. And started photosynthesizing. Okay, so what happens? So photosynthesis, so changing carbon dioxide into oxygen. Okay, so that actually changed some of the atmosphere as well. Okay, so other plants developed over time to photosynthesize more and create the atmosphere as we know it today. Okay, so you can see amounts of oxygen. Also, other things do biological, lots of things about life changed it. Was the nitrogen formed as the so nitrogen formed as the ammonia that was present. So there's a little bit of extra information here that's not been told up there. The ammonia that was present in the early atmosphere reacted with oxygen and denitrifying bacteria. So you've got the nitrogen cycle featuring here. Denitrifying bacteria. So yeah, there's a bit of extra information from biology, because all the sciences do actually cross over, because it's much better to see it as sort of a cross-disciplinary thing. Science is that the life on Earth, the life that develops on Earth, keeps the carbon dioxide and nitrogen stable with the carbon and nitrogen cycles. So humans are causing these cycles to be disrupted. Okay, so yeah, naturally the Earth will rectify itself. I mean, eventually it will, even with human interaction, but saying it might not very quickly, and obviously it might make the climate change, and obviously make make it obviously uncomfortable for us, okay, to live in. So obviously we don't really want to contribute too much to that. Okay, so yeah, so summary. So surface has changed. The early Earth was covered in volcanoes and was mostly molten. So over time, the Earth's surface has cooled down, solidified to form rock. The water vapor was in a gaseous state because the early Earth was so hot. This cooled down and condensed to form the oceans. The oceans were also formed from comets, so they're made of ice and rock colliding with the Earth. Once the oceans formed, the carbon dioxide in the atmosphere could dissolve in the oceans. Carbon dioxide was formed in the carbonate rocks in the oceans, that's limestone and chalk. Over time, the surface of the Earth formed a crust, which was cracked in places, like we said, like a boiled eggshell, if you sort of cracked it, and formed the tectonic plates. So these tectonic plates moved around and formed the continents. So in the atmosphere, algae evolved and started photosynthesizing. So that's mainly in the oceans that happened, changing carbon dioxide into oxygen. Other plants developed over time to photosynthesize more and create the atmosphere as we know it today. nitrogen formed as the ammonia that was present in the early atmosphere reacted with oxygen and denitrifying bacteria. Okay, so in humans, are disrupting the cycle. So yeah, it's good to read up on all of this and watch videos. Very interesting. Okay, I hope you've enjoyed the class today and may have learned something. So thank you, and I hope to see you in another video. Goodbye.